Okay. How many other points?
I'm not done.
Okay.
Wait, okay. Is there easier way to multiply those out?
No, no more.
Then, okay, go ahead.
All right. Where do critical points occur?
When the
The derivative is equal to 0. So your task would be to take the derivative, and this is a product. So the derivative of this would be the derivative of the first term, 5x minus 2 to the fourth, times the second term, plus the first term, times the derivative of the second, which would be 4x minus 3 to the third. Okay, so there's the derivative. You have to set it equal to 0. Pretty messy to solve, but notice that there are some terms in there that you can do what? Factor out. You can factor out an x minus 2 raised to the fourth. You can factor out an x plus 3 raised to the third. If you do that, you're left with a 5 here, x plus 3, and you're left with a 4 times x minus 2. I think everything else was factored out. Okay? So then this gives you 5x plus 15. This gives you 4x minus 8. So we have 9x plus 7 inside there. So you got a product of 3 terms equaling 0. So there are 1, 2, 3 places where the critical points will occur. Okay? So 3 critical points. All right. Okay, ready for the last lecture of try 2? Last section of 10.6.
This is the last slide.
Last lecture of 10, chapter of try
I want to try to. I have to.
See, her emails go to an email I don't use anymore, so I check it out. But I'm gonna check it.
What's the polar equation for x? Polar coordinates. R equals sine theta. Remembering that r is also a function, and y is r sine theta. Okay, our task today is to find the length of the curve, and then once we find the length of a curve, figure out the surface area of a figure. So, how do we find the length of the curve? Remember, we did it with parametric equations. Well, this is basically a parametric equation. It's just dealing with theta and r instead of t. And so, to find the length of the curve, we just found a little portion of it and added all those portions. So we need to integrate. And what's the length of each of these sides? Well, that's the change in x compared to change in theta. So this is dx d theta. That's how much that part's changed. How much has this changed? dy d theta. And then we use Pythagorean's theorem to figure out d. And so the length of the curve, we already have this formula. It's alpha to beta, square root of dx d theta squared plus dy d theta squared d theta. That's exactly the formula you had with parametrics, except we use t. All right? Now, the difference here, of course, is we have a function that has an r in it, which means there's more than just the theta, there's the r of theta. So we can simplify this a little bit by expanding it out. So I'm going to expand it. dx d theta is the derivative of x with respect to theta. So let's see if you can remember how to do that. R prime times cosine of theta plus r times the derivative of cosine, which is negative sine, so this is a minus. Minus r sine of theta. Okay, so that's the derivative of x with respect to theta. All right? And we have to do what with that? Square it. Plus dy d theta. So now we're taking the derivative of this with respect to theta. So r prime sine of theta plus r times the derivative of sine, which is cosine. Okay, so that's what you're going to get when you take the derivative. But now let's expand it out because it does simplify down quite a bit. So this is going to be the integral. It's going to be a square root. Well, what do we got to do? We got to square both of these. Can you do it in your head? Can we do it in your head?
Yeah.
Okay, we're using the FOIL method, so it's r1 squared cosine squared. You square the first term. So r1 squared cosine squared. Then we're going to have two middle terms, or the middle term, because it's going to be this times that, and then that times that, so you're going to have two of them. So it's going to be 2 minus 2r prime r times sine theta cosine theta. Now that's just, it's just like when you square a plus b squared. You're going to have a squared here, or a minus, and then you're going to have a minus 2ab there.
Is it important for us to be able to know how to do this, or?
No, we're dividing it. Okay.
Okay, but I'm not going to break it.
Okay. Plus this thing. Well, you should be able to do all this. Okay. Plus this squared, which is r squared sine squared. Okay. Now let's square the next one. That's I prime squared sine squared. Plus 2r prime r sine cosine. Okay. 2r prime r sine theta cosine theta. And then plus r squared cosine squared. All right. But now this is going to simplify down because this term here and this term here,
No, the next one,
no, these, they both contain an r prime squared.
right?
So I'm going to put them together and then do what? Factor out the r prime squared. So I'm going to factor out the r prime squared, and that's going to leave me with the cosine squared plus sine squared, which is 1. Okay, that's adding these two together, just putting them together, factoring out the r prime squared.
And the two are
And what happens to this one and that one? They cancel out. And then these two here both contain an r squared, so I'll add them together and factor out an r squared. And that leaves me with sine squared plus cosine squared again. And then this whole thing is the square root, of course.
so much
And so, what does this equal? Equals 1. That equals 1. So we end up with the integral that goes from a to b, or alpha to beta, r prime squared plus r squared d theta.
Can you factor? No, you can.
No, you can't factor anything out. But I'm going to rewrite it a little neater. And put the r first. And what is r prime? It's the rate of change of r compared to theta. So dr d theta squared. So that you realize what it is. And so there's the formula that you can find the length of a curve using parametric or polar coordinates. This is the same equation. Oh.
We just couldn't miss it.
All right.
We just couldn't go home.
All right. How you doing? Okay. So, in answer to Catherine's question, no, you don't have to know how to do this. This is all the formulas you're going to need. But rather than just magically giving you, you should see how they come. Okay, let's try an example. Okay, kind of keep using the same shape, but that's okay. Find the length of this curve. I'll leave that on the board for now. So it's produced by r equals 1 minus cosine theta. Now remember, how is this curve produced? It's produced by an angle and an angle that's being revolved around. So when the angle is 0, put a 0 in here, the radius or the length is 0, that's why it starts there. When the angle gets up to pi over 2, cosine of pi over 2 is 0, so the r is now 1. When the angle gets to pi, you put a pi in there, it's 1 minus a negative 1. That's why it's at 2. When the angle gets down to 3 pi over 2, cosine 3 pi over 2 is 0, so the radius is 1. And why is it 1 and not negative 1? Because it's the direction that the angle is going. And the angle is going this direction, so that means it should be a positive 1 value for r.
Wait, why is it 2 and not negative 2?
It's located at negative 2.
Okay.
And the distance is 2, sorry.
Oh, yeah.
It's located at negative 2, but the angle is pointing in this direction, and it's a positive 2 in that direction. And then, of course, sweeps all the way around 2 pi. We're back to 1 minus cosine of 2 pi, which is 1 minus 1, or back to 0. Okay, now find the length of the curve. Length of the curve is alpha to beta. R squared, what's the r d theta? That's what I have to do, plug it in. So, what is alpha? What is beta? To create this curve, how big of angle did we have to go? 0 to 2 pi. R squared is 1 minus cosine theta squared. The r d theta is sine of theta. Sine of theta squared. Okay. Which you could just plug in your calculator, but I think you should be able to visualize that it's going to simplify. Why is it going to simplify? Because when you square this, you're going to get a cosine squared to go with a sine squared, so things will simplify down. So this becomes 1 minus 2 cosine theta plus cosine squared plus sine squared. And then this here becomes a 1. So take that 1 and add it on that, and you get 2. So the integral, it's still a square root, but it's 2 minus 2 cosine of theta d theta. A little bit easier number to plug in your calculator, less chance of an error. Okay? So that's the length. All right. Next one, surface area.
Do you have numbers? Typewritten notes?
You don't have what?
Like handwritten notes that you like copy?
Yes, I do have some I can get for you.
Okay.
I don't know. Well, let me finish here and then I'll get it.
Yeah.
Okay. All right, remember, how did we find surface area? We found the length of a curve, and then we revolved it around the axis a distance of 2 pi, whatever the radius is, it's revolved. It's if it's the x-axis. If it's the y-axis, we do the same thing, but it's revolved around the y-axis. So, surface area about the x-axis. That means we're going to take this curve here, forget about all the other stuff, just take this part of it and revolve it. It's going to have a radius of this distance, which is the y value. And so we're going to have to multiply it by 2 pi to get the full circumference. So surface area about the x-axis is going to be alpha to beta. The length of the curve, which we've got, is r squared plus dr d theta squared theta. And we're going to take that curve, revolve it a 2 pi distance, so it's going to be 2 pi times 1. What if it's revolved about the y-axis? Now the curve, this thing here is going to be revolved this way, so whatever distance is being revolved, it's going to be an x amount. Now it's kind of goofy because that part's x, and then of course this part here is x going that direction. It's going to be a real funny shape because it goes in. So this is going to be the inside part, and that's going to be the outside part of the curve because it's got a shape like that. You with me on that? It's kind of a goofy three-dimensional shape. But all you have to remember is what? You're revolving this length, whatever it is, around the y-axis, a full circumference, which is 2 pi times whatever the x point is on the curve. So, just pick any point of the curve. That's going to have to be revolved at 2 pi x amount. So the formula is exactly the same thing. It's 2 pi x, and then the length of the curve is the same. Okay.
Looks like
Maybe it's negative 5.
I mean, it's a little bit.
All right, last problem, last example. Try to find the surface area if that parametric or polar coordinate is revolved about the y-axis. So what you need to do is get a picture of what's going on. So I'm going to solve for r. R is going to be plus or minus the square root cosine 2 theta. All right? Put that into your calculator, and you're going to get a shape going to revolve it about the y-axis and create a shape, and then we want to know what the surface area is of the shape. All right? So, surface area. It's going to be an integral. It's important to know what the angle is. Because to create this shape, we don't have to go all the way around. We only have to go what?
Halfway.
We only have to go from here to there. Because that creates this shape. You know, if I go from here to there, that creates that shape. And then if I revolve that around the y-axis, that's all I'll need to create the shape. You with me? So that's the first thing you have to figure out is we don't need 0 to 2 pi to create this. We only need to go from, well, let's find out what we need to go from. The function is r squared equals the cosine of 2 theta. What is the length of r right there where it starts? 0. And then what's it going to be when it gets back to that point? 0. So essentially, we need to solve this equation. Because that will tell us what the angle is that will produce that point of 0. So when's the cosine of 2 theta equal to 0? Well, when's the cosine equal to 0? When the angle is pi over 2. So that means that 2 theta, has to equal pi over 2. So theta has to equal pi over 4. Which also works going down here because you're going to have a 0 down here at negative pi over 2. So set this equal to negative pi over 2. Theta is equal to negative pi over 4. Bottom line is the angle that we're going to integrate from goes from negative pi over 4 to pi over 4. So we go negative pi over 4 to pi over 4. Okay, we're revolving about the y-axis. So we're using this formula. So it's 2 times pi times x. What is x equal to? X is this value here. What is x? I started the whole lecture out with it.
R equals cosine theta.
What is it?
R equals
R cosine theta. The x value is r cosine theta. So we go 2 times pi times x. But what is x? X is r cosine theta. What is r? The square, we'll just deal with this positive part. R is the square root of cosine of 2 theta. So the square root of cosine of 2 theta times the cosine of theta. So this is r times cosine of theta. So the x is equal to r cosine theta. This is r, that's cosine theta. And then we have to multiply it by the square root of r squared. Well, what's r squared? That's easy. That's the cosine of 2 theta. So this is your r squared plus the derivative of r with respect to theta squared. So we need to take the derivative of r. So r is equal to cosine of 2 theta to the 1/2. We need to figure out dr d theta. So what's the derivative of this? 1/2 cosine of 2 theta raised to the negative 1/2 times negative sine of 2 theta times 2. Okay, everyone comfortable with that? So then we put that in there. Why don't we clean it up? We get the 2's will cancel. We get negative sine of 2 theta on top, and we get the square root of cosine of 2 theta on the bottom. Negative square root on the bottom. Okay. That's the derivative of r. We put that in there, and we do what with it? We square it. So we get minus sine of 2 theta over the square root of cosine of 2 theta squared. basis. Okay, let's bear with. What do we got? We got the integral. Actually, the integral is symmetric, so we can clean it up even more. Instead of going from negative pi over 4 to pi over 4, we can go from 0 to pi over 4, and we double the ends. There's no reason to do all of this, just do half and double your ends. So we go from 0 to pi over 4 times 2.
Can we pull out the 4?
And yeah, you can bring out the 2 pi, so now it becomes 4 pi out here. So I brought the 2 pi out and doubled it. Okay, so now I get the square root cosine of 2 theta times cosine of theta. And let's clean up this mess here. This is the cosine of 2 theta. Plus, what's this become? Positive sine squared 2 theta over just the cosine of 2 theta, because we squared the square root. All right, common denominator is cosine of 2 theta, so we can multiply top and bottom by cosine of 2 theta. All right, so that's going to give us 4 pi. 0 to 4 pi, pi over 4, square root cosine of 2 theta, cosine of theta. I just repeat that. Okay, I'm multiplying top and bottom by cosine of 2 theta. So that gives me what on top? Cosine of squared of 2 theta plus sine squared of 2 theta all over the cosine of 2 theta. The whole thing is under square root. All right, now it should be clearer what's going to happen. What is cosine squared plus sine squared? 1. 1 over the cosine of 2 theta square root times the square root of the cosine of 2 theta. Completely cancels out. This cancels out with this whole thing because this is 1 over the square root. And so we end up with 4 times pi, 0 to pi over 4 cosine of theta, d theta as the surface area. Which works out becomes 8.886. And it also can be done by hand because at that point the integer is. All right, there we have it. Ready. This becomes a 1 over the cosine of 2 theta.
And
And
then
that becomes canceled with this. Now I left this cosine. All right, so it was supposed to be a 2-day test, and somehow we lost a day. It might have been my extra student trip or something, but we lost it. So I'm going to cut the test down and just move about half of what we were going to do. And then no notebook check again Thursday. We won't have to do any review problems. Notebook check just no review. There's review problems listed, just the section 2, section 6. All right. All right, go back to sleep. Seriously. Yeah. We just brought it outside and we doubled our integral.